Good evening. I'm Spot On Weather meteorologist Matthew Euler, and tonight we're going to take a look at the United States weather. Looking at this map here on the title slide of tonight's training presentation, you'll notice this is a topographical map, and the United States as a whole, from the west to east coast, is influenced greatly by significant geographical features. For example, we have the main Rocky Mountains that mountain range running from western Montana on through southwestern Wyoming down into Colorado, even extending further south towards New Mexico. And that plays a large role in the type of weather that we see both on the windward side as well as the leeward side of that mountain range. Additionally, we have a lot of flat land, generally between Nebraska, the Dakotas, down through Kansas, Oklahoma, eastward to the Appalachian Mountains, with the Appalachian Mountains running from northeastern Georgia up through western North Carolina, western Virginia, on up into Pennsylvania, the Appalachian Mountains of the East Coast, or the eastern U.S. as a whole. And then, of course, we're surrounded by many different ocean areas, the Atlantic Ocean on the east, the Pacific Ocean on the west. And so there's a lot of variability in our weather based on these geographical features. And I really hope you enjoyed tonight's video, so let's go right into the United States weather. Generally, the weather in the United States is going to be typical of all weather types within the temperate regions. When I say temperate regions, I'm referring to mid-latitudes of the North American, the European, and the Asiatic continents. The general circulation is going to be influenced by the prevailing westerly wind belt. All closed surface weather systems, whether they be high and low pressure systems, they generally tend to move in a west-east direction. The jet stream generally guides along these surface weather systems. Additionally, cold fronts tend to move southward in the northern hemisphere across North America and the United States, and warm fronts generally tend to move more northward. Again, as I've alluded to just briefly here to open up the video tonight, the certain geographical features of the United States play a significant role in the type of weather we see, as well as the climatic conditions or that average weather. They tend to make specific areas more favorable for the development of low pressure systems, such as West Texas, Cape Hatteras, central Idaho, and the northern portions of the Gulf of Mexico. And I will show you some general storm track climatology toward the end of tonight's video. Storms or low pressure systems that generally form along the polar front, especially in wintertime. These systems really do impact the United States. And you can see a generation or even a regeneration of a low pressure along the trailing edge of these fronts. Much of the winter season weather in the United States, much of the winter precipitation across the United States is influenced by these mid-latitude cyclones. Additionally, in the summertime, when the pressure gradient relaxes, the main jet stream goes to the north, retreats to the north along the U.S.-Canadian border. You get less upper-level dynamics. Much of the United States is dominated generally by air mass weather. This generally is referring to the fact that the air mass really doesn't change very much from day to day through the summer months. Generally, it's the net effect of local surface circulation, smaller scale effects, land sea breezes, for example. If you live in the vicinity of mountainous terrain, you can have upslope and downslope type winds. So we're talking more of smaller scale weather phenomenon. Additionally, a modifying effect of significant water bodies. We must consider that during air mass weather. And what we typically see, especially across the eastern United States, is what's known as air mass thunderstorms. If you look at the graphic on the bottom right, this shows the developing stages of a typical air mass thunderstorm. These thunderstorms do not last very long. Sometimes the average pretty much referring to about 30 minutes on average. There's the stages there in the lower right, starting off with the towering cumulus stage, on the left, where the cumulus cloud begins rising in the vertical due to these convective currents from the heated surface below. That then develops into what's known as a mature stage, where we get both updrafts, upward motion, as well as downdrafts or downward motion in a thunderstorm cloud. And you do start seeing the rain during the mature stage. It starts reaching the surface there on the downdraft region of the air mass thunderstorm. Finally, we get to the dissipating stage where the thunderstorm pretty much decays or dissipates. So this is quite common across the eastern United States during the summer season. We get those pop-up afternoon thunderstorms. The air mass is very warm and moist. We have the Bermuda high pressure system situated off the east coast of the United States, pumping in warmth and moisture on a daily basis into many cities in the U.S., in the eastern U.S. Here's again a look at the United States topography as a whole. Generally, the browner shadings, that generally indicates higher elevations. The green shadings indicate areas closer to sea level. So again, some of the major mountain ranges affecting the United States. We do have the Cascade Range, by the way, up in the Pacific Northwest, there in parts of Washington State, Oregon. We also have the Sierra Nevada mountain range down in California, which can be known for very prolific snowfall amounts during the winter season. Additionally, as I alluded to earlier, we have the Rocky Mountains, which run generally north to south, and they play a significant role on different types of average weather or climate for specific locations, depending on if you're on the windward side of those Rocky Mountains across the western U.S. or on the leeward side. Typically, the windward side locations receive more annual precipitation, as well as generally tend to have cooler temperatures as compared to the leeward sides, where the air sinks and compresses, dries, and warms. In the eastern United States, you'll see the influence of the Appalachian Mountains there, indicated by the brown shading, stretching from Pennsylvania down through, again, West Virginia, parts of western Virginia, western North Carolina, down through western South Carolina into northeastern Georgia. Additionally, there are a few local mountain ranges up in New England area, such as the Adirondacks of New York State. So there are some higher elevations. Mount Washington is another high elevation location up in New England. Again, this plays a significant role in the type of weather many locations see, this geography. All right, so when I go through the different regional areas and the normal average type of weather that are seen, I divided the United States up into these main regions. We have the Northwest Pacific Coastal region, the Southwestern Pacific Coastal region, the West Central Intermountain region, the Southwest Desert and Mountain region, the Central Plains region, which takes up a large amount of real estate in the middle of the U.S., and then the Southeast and Gulf states, as well as the North Atlantic coastal region. So this is the way I'm going to break down tonight's general weather conditions that we see in the United States. So we'll start off first with the Northwest Pacific Coast area. So this would include the areas of western Washington State down through Oregon, a good chunk of Oregon, down through Northern California. So let's take a look at what type of weather those type of areas see. The Northwest Pacific Coast area typically has more precipitation than any other region in North America. The weather is primarily the result of frontal phenomenon, consisting of mainly occlusion-type systems, which move in over the coast. So these occluded fronts coming off the Pacific. The circulation around the Aleutian Low is generally counterclockwise, and that's going to allow for moist and stable maritime air to be orographically lifted in the Northwest Pacific Coast area. Again, in that particular area, we're looking at the Cascade Mountain Range, for example. And when that warm, moist air rotates around the Aleutian Low in the Gulf of Alaska, that will allow that air to be lifted as that blows up against the windward side of the Cascade Mountain Range. The predominant cloud forms are generally stratus or layer-like clouds along with fog, which is quite common in all seasons, especially in locations such as Seattle, Washington. Rainfall is going to be most frequent in the wintertime when you get multiple storm systems that come in off the North Pacific Ocean. and they're least frequent. Storms are least frequent in the summertime, which obviously leads to less rainfall. Here's an example of Seattle, Washington. This is a Climograph showing average monthly precipitation and temperature. The red line on all the Climographs I'm going to show represents the average temperatures, and those green bars represent the average precipitation. So we have precipitation in inches on the left in the vertical, and then we have temperatures in degrees Fahrenheit on the right. And at the very bottom, across the horizontal axis, we have the months, January to December. So a place like Seattle, Washington, typically sees quite a bit of rain, especially in the months of November, December, and January. Can extend into March, where Seattle averages around 4 inches of rain, even down into parts of April, where they still get just below 3 inches. But then you notice the summers and how those green bars really get shorter, indicating a drier weather pattern for Seattle in the summer season. Generally, the temperatures in January, really December and January are the coldest times of year, where the average temperature is about 40 degrees Fahrenheit. So you'll notice in the summertime, in July and August, those are the warmest months. Average temperature are just above 60 degrees Fahrenheit. Now, Seattle, Washington can get very warm. This is just an average. Keep this in mind. It can also get very cold in the winter, and there could actually be snow that has been recorded at SeaTac Airport, for example, in Seattle. So this is just average, and there are extremes, both cold and warm. Just keep that in mind. Now we'll turn our attention to the Southwest Pacific Coast area. So let's look back at the map. Southwest Pacific Coast area mainly covers central and southern California. Generally, this type of location experiences what's known as a Mediterranean type climate and is distinctively different. A Mediterranean climate occurs over Southern California specifically. Weather is generally characterized by warm to hot summers, tempered by sea breezes, and mild winters, which temperatures seldom drop below the freezing point, 32 degrees Fahrenheit. And there's usually little or no rainfall occurring in the summertime, and only light to moderate rain in the winter. When you get these storm systems, a lot of times you get these upper level low pressure systems that will basically come down from the northwest off the Pacific Ocean and pivot into Southern California, and that gives them quite a bit of their annual precipitation. It very rarely is going to rain at all. It's very uncommon in the summertime across places like Southern California with this Mediterranean climate. Cold fronts rarely are going to penetrate this region. Weather is due to circulation of moist, acidic air from the west being forced up the slope of the coastal range. So in California, we also have what's known as the Pacific Coastal Range, which has some higher mountain areas. In the summertime, the air is stable, with stratus and fog quite common. In the wintertime, the air can be unstable at times. You get these cold pockets of air aloft, these upper level lows. If that moisture and that moist and unstable air is forced up over the mountain ranges, this is going to result in showers or even snow showers in the mountainous areas. All right, so for the Southwest Pacific Coast area, we're going to use San Diego, California Climograph to kind of describe the weather you would see. All right, so big difference here between Seattle and San Diego, right? Look at how much shorter the green bars are for San Diego, California. Generally, they get the bulk of their annual precipitation in the months of January, February, and March. And a phenomenon known as El Nino can lead to wetter winters, even more precipitation of this, and flooding across Southern California. Look at the summertime in San Diego. The months of June, July, and August see basically next to nothing as far as measurable precipitation, before things ramp up again in November and December a little bit. But in general, no month shows anything really greater than just over 2 inches of rain. If you look at the temperature profile there, the red line, the coolest months tend to be December as well as January, where the average high temperature is about 58 degrees Fahrenheit. And you'll notice in August, September, you get the warmest temperatures of the year, generally with highs averaging above 70 degrees Fahrenheit. Now, What happens during the August-September time period, even in October, is you can get a greater frequency of these offshore winds, which basically pushes the marine layer air further out to sea. This is known as the Santa Ana winds of Southern California, and they definitely cause a lot of fire problems. Fire season really ramps up, especially in August, September, and October in Southern California because of this predominance of offshore winds, or what's known as the Santa Ana winds. And generally what you get are stronger high pressure systems that migrate from the northwest down into the Great Basin area. And these high pressure systems, the clockwise flow around them directs the winds to be more offshore in this part of the United States. So in general, it's a fairly dry climate in Southern California. And personally living there for a few years, we hardly got any rainfall really, except occasionally in the winter time, and that was pretty much it. A lot of low clouds, fog, and stratus are common, and sometimes you get a little bit of drizzle, but like I said, that outside of that and the occasional passages of upper level low pressure systems, that's it for San Diego. Now let's turn our attention to the Intermountain West Central area, and that is located generally over eastern Washington, parts of eastern Oregon, as well as Montana, Idaho, those locations. So let's see what they get for average weather in the United States. So this area does include the Great Plains region, located east of the Cascade Range and the coastal ranges. It's west of the Mississippi Valley and north of the southwestern desert area. Weather is generally cold and dry in the wintertime, and warm and dry in the summer, and most of this region is actually semi-arid, with the western mountain range acting as a climate barrier, with extreme drying on the eastern side of that mountain range. As the air dives down the eastern side of the mountain range, it becomes much drier and warmer, and that results in semi-arid areas. Maximum rainfall occurs in the spring due to the predominance of cyclone passages. You have a lot more cyclones moving through, or storm systems, at that time of the year in spring. In midwinter, you get these really cold, high-pressure systems descending from Canada over the region, which keeps the storm track blocked pretty much. Annual precipitation is normally light. We chose Great Falls, Montana Climograph to exhibit this particular region, and look at the red line and how much more steep it is as compared to places like Seattle, Washington, and San Diego, California. This is due to the fact that Great Falls is located in the interior portion of the United States, away from the modifying effects of the Pacific Ocean. So generally, Great Falls, Montana receives the majority of the most amount of precipitation, represented by these blue bars, up to about 3 inches of rain in June. Generally, April, May, and June have an upward trend in the precipitation amounts. If you look at the months of July and August, as well as November, December, there's not a whole lot of rain that Great Falls, Montana receives during those months. If you look at the red line, the temperature line, there's a wide range of temperatures ranging from just about 25 degrees Fahrenheit, the coldest months in December, January, and February. And then you'll see that pretty steep incline, or that climb, just over the warmest month is July, which is just over basically about 72, 73 degrees Fahrenheit in Great Falls. And then you see that drop off again, and especially from September through December. So a wide range of precipitation and a much larger swing in the annual temperatures in a location such as Great Falls. Moving on to the Southwest Desert and Mountain area. This includes Lower California and some of Southeast California, as well as southern portions of Arizona, New Mexico, and Texas. This area is almost completely surrounded by high mountains, and it's very arid, or actual desert, with annual rainfall rarely exceeding 5 inches, so super dry desert areas here. The northerly sections have cold winters, and all parts have extremely hot summers. And the chief flying hazard, if you're a pilot, that's generally going to result from spring and summer thunderstorms caused by maritime tropical air being forced aloft over the mountains. This particular area has what's known as a monsoon season, primarily in the month of July into early parts of August, where you get this maritime tropical air, this warm, moist, and stable air to come in from the Gulf of Mexico. And, you already got a lot of heat in this area, very hot temperatures. So very unstable situation with lots of showers and thunderstorms. So this area does get a lot of its annual precipitation during the summer monsoon time of year, the summer season. We chose Phoenix, Arizona to represent the type of annual precipitation and temperatures you'd see in the desert southwest area. And in general, you notice the blue bars represent your annual precipitation. The red line is your average temperature. Look at the spike in the average. In the wintertime, it's pretty healthy. Generally below 1.2 inches in December, and then that climbs to just under 1.4 inches in the month of January for precip. And then February is the wettest month in Phoenix, where we typically see 1.5 inches of precipitation. And then you'll see that major drop-off in April, May, and June. In fact, June's precip only averages about a tenth of an inch. That's it in Phoenix. And those temperatures, comfortable in the wintertime. Generally, December, you're averaging just above 50 degrees Fahrenheit, about 52 degrees average high in the month of December in Phoenix, as well as January. And then you see that really steep climb. Average high, the hottest month in July, is actually 95 degrees Fahrenheit in July. That's the average high temperature for Phoenix, but it can get much, much hotter than that. It can easily exceed 100 degrees on quite a few days throughout the year. Temperatures do cool off then from September, October into November, as there's a drop-off again in that red line, the temperature line. Now let's take a look at the Central Plains area. Let's go back to the map. Central Plains area generally covers the North and South Dakota area, Nebraska, Kansas, parts of Oklahoma, a good chunk of Oklahoma, Arkansas, up through Missouri, Illinois, Wisconsin, those type of locations. So let's see what that weather looks like in that area. This generally includes the continental climate regions of the Great Plains, Mississippi Valley, Appalachian Plateau, generally between the Rocky Mountains to the west, the Appalachian Mountains to the east, and the Gulf states to the south. The western section of this area is generally drier than the eastern section, and wintertime outbreaks and associated cyclone wave phenomenon along polar fronts causes the main weather hazards. And you get convective air mass type thunderstorms are also prevalent in the summertime, and they do pose a significant threat to flying, obviously due to all the turbulence, the heavy rain showers, reduced visibility, as well as the very strong downdraft and gusty winds. Now you do see a lot of warm and cold frontal passages in mid-latitude cyclones. Thunderstorms are usually of convective origin and are most violent, developing a maritime tropical air mass. They often occur in spring with higher frequency tornado activity. Now I wanted to show you what Central Plains tornado climatology looks like. This is the average number of tornadoes per year, with the orange and the maroon shading representing the greatest number of tornadoes per year per 10,000 square miles. So orange and red areas are the hot spots. You'll notice generally from northern Texas through the central part of Oklahoma, including Oklahoma City, that has the highest frequency of tornadoes in general over a 10,000 square mile area. Further up in the orange shading, parts of Kansas are also considered to be very high areas for tornadoes, as well as eastern Nebraska. And there's another hot spot there, if you notice, over northern Illinois and northern Indiana, where there's quite a few tornadoes. And that's due to a lot of the clash of the air masses, cold air coming down from Canada, meeting up with the warm, moist air from the Gulf of Mexico, and really gets things going along those frontal boundaries across the Midwestern U.S. Just wanted to show you this. This is a great graphic that kind of shows the overall tornado climatology. I decided to use Des Moines, Iowa Climograph to describe this area. And generally, there's a significant range of annual temperatures from January at 23 degrees Fahrenheit in Des Moines, all the way to the warmest month there in July, where the average high reaches 77 degrees Fahrenheit. And then you see a major drop-off in that red line there from August through December, as the daylight hours get shorter, the sun angle decreases in the sky, and we have a change of the seasons from fall to winter. If you look at the blue bars, the precipitation amounts, the average amounts per month, January through December, you'll notice that the driest month is actually in January, where Des Moines, Iowa receives generally about 1.5 inches of precipitation. Now you got to realize that's going to fall in the form of snow in many cases across Des Moines. So in general, 10 inches of snow is equal to 1 inch of liquid. So if I say 1.5 inches is the average liquid equivalent in Des Moines in January, that could actually equate to 15 inches of snow. Generally, you see the wettest month in Des Moines is typically in May, where they average 5.5 inches of precipitation. That occurs a lot due to the heavy thunderstorms, strong to severe thunderstorms that move across this particular area of the United States. And then there's a drying trend, and especially in the fall, from September, October to November, down into December. But again, that December time period can be dominated or influenced by frozen precipitation. Again, the ratio of 10 inches of snow is equal to 1 inch of rain or 1 inch of liquid. So in general, there's your Climograph for Des Moines, Iowa, and the temperatures range from about 23 in the coldest month up to 77 in the warmest month. So quite a range in temperature. That's generally due to the fact that Des Moines and Iowa is the center of the United States. Again, very limited influence of any water bodies to modify this climate. So very continental in nature. Now let's take a look at the southeast and Gulf states. This includes all the states bordering on the Gulf of Mexico, as well as South Carolina and Georgia. So let's take a look at that map for the southeast and Gulf states. Generally, it's going to be right there in the bottom right portion of this diagram. So southeast and Gulf states would include Florida as well, parts of Louisiana, Mississippi, Alabama, and Georgia, up into South Carolina. So what type of weather does this area typically see? Let's take a look. Typically, this area sees stagnating southbound cold fronts, rapidly moving squall lines out ahead of cold fronts, air mass thunderstorms in the summer season, and then stratus clouds occur in various combinations year-round. Frontal passages generally are confined to late fall, winter time, and early spring across this particular area. Circulation phenomenon known as the Gulf stratus affects this area, and I'll show you what that looks like here in a moment. In winter, when the circulation near the surface is southerly, you can get this warm and moist air moving in from the Gulf of Mexico, which is cooled from below to saturation over that cooler ground. And when this occurs, fog and Gulf stratus may form and persist over the area for several days. Let me tell you something, just out of experience, I lived in the Florida Panhandle for a few years. If there's one thing that is really amazing to watch unfold in the winter season in the Florida Panhandle, not far from Pensacola, is the development of thick fog, especially overnight. When the nights are longer during the winter time, you tend to get the temperature to cool more efficiently. As that temperature drops, it cools close to the dew point. In general, if you get a southerly wind, I've seen it a lot of times over that area, in addition to when you get these cold fronts to clear the Gulf Coast, but then you get these areas of low pressure to form in the northern Gulf, and they direct southerly winds over cooler ground, and that results in very thick fog. I've seen visibility in these situations go from 5 miles down to less than a quarter mile. That's how thick the fog can get in the Florida Panhandle, especially parts of southern Alabama in the wintertime. Really interesting. Now, the southerly circulation in summer, that's a completely different story. It's very persistent. It causes warm, moist air to be heated from below, and you get these afternoon thunderstorms which occur almost daily. Since the air is generally moist and unstable, these storms are generally severe. You get some really good, strong to severe, lots of cloud-to-ground lightning with these very long-lasting thunder, rumbles of thunder, and very heavy rainfall, gusty winds. That's the most common aspect of these storms during the summer season across the Gulf Coast states. And you may be driving along Interstate 10 and be fine one minute, and then you run through one of these like heavy shower or thunderstorms, and your visibility, your wipers cannot move fast enough to be able to see. I've been in these type of storms in Mississippi, and sometimes the best thing to do when the rain is coming down so hard because the wipers are ineffective is just to pull over off the side of the road and wait for this thing to rain itself out. So if we take a look at these Gulf stratus situations in the winter, look at the gray shading there along the southern U.S. there along the northern Gulf Coast states. That gray area generally indicates days. These are the annual number of days with heavy fog, and the visibility is generally less than or equal to a quarter mile viz. And so those dark gray shaded areas there, that indicates 30.5 to 35.4 days of the year is where you see these Gulf stratus events, again, where the visibility is very, very low, and it happens very frequently. Growing up in the Midwest, some of the more significant hazards of winter in the Midwest are the snowstorms reducing visibility, as well as ice storms. But in the Gulf Coast states, southern Alabama, Florida Panhandle, parts of South Mississippi, it is the heavy fog that rolls in, this advection fog, especially, which will really sock your location. Another aspect when we talk about the summer season, there's a secondary area of higher tornado frequency. This is known as Dixie Alley. And this typically occurs across just there in eastern Arkansas, especially into Mississippi and western Tennessee. And you get a lot of tornado activity there, especially during transition seasons. I'm talking in the fall, where you get the really strong cold fronts coming down from the north, running into that warm and moist maritime tropical air mass. You get them in the fall, and you can also get a higher frequency of tornadoes in Dixie Alley in the spring, especially like February timeframe, where some of the warm, moist air is trying to push north up against the much colder Arctic air, which resides to the north of the area. It makes it very strong to severe thunderstorms, and you can get these tornadoes and this curvature in the wind field. So I wanted to definitely show you that as well. We usually think about the Central Plains as the tornado capital. The majority of tornadoes occurring in the Central Plains, but there's a secondary area here that is definitely worth mentioning. Here is Pensacola, Florida's Climograph for this particular area, southeast Gulf states. And you notice this precipitation is pretty high throughout the year. It doesn't matter what month we look at. The lowest average monthly precip is going to be in May, and you're still looking at 3.4 to 3.5 inches on average in the month of May in Pensacola. Look at July, August. August, your average monthly precipitation is nearly 7 inches of rain. So generally, the area is influenced by these frontal boundaries and these storm systems in the winter season, the mid-latitude cyclones. In the summer season, the precipitation is greatly influenced by these air mass thunderstorms, those convective thunderstorms that develop on a daily basis that dump a lot of rain, as well as tropical cyclones. I will show you a tropical cyclone map here at the end of the presentation. If you look at the red line, the average temperatures from January to December, the coolest month is generally in the month of January, where your average high temperature is about 53 to 54 degrees Fahrenheit. That rises up to the warmest months of July and August, where the average temperature is generally into the 80s by this point. Now, the comfortable time of year in Pensacola, Florida, if you don't like humidity and heat, is definitely between November and January. And finally, we'll talk about the North Atlantic coastal area. So let's go back here and examine what states are in that area. Okay, North Atlantic coastal area includes North Carolina, Virginia, West Virginia, Ohio, Kentucky, eastern part of Kentucky, generally up into New England area, New York State, Connecticut, Vermont, New Hampshire, Maine, New Jersey. That's the North Atlantic coastal area. So let's take a look and dive into that area. All right, so this is an area of storm track convergence and has frequent cyclone activity, especially in the wintertime. You get a lot of development of offshore low pressure systems, and they move up the eastern seaboard. These are known as nor'easters. The heating and addition of moisture to the overlying air, if we look back in the Great Lakes areas, generally heating from below and unfrozen water bodies of the Great Lakes is going to intensify storm systems. Lake effect is directly responsible for large amounts of snow often found leeward of the lakes, Great Lakes area over in the wintertime. And you get generally good weather prevailing in the summertime due to the influence of the Bermuda high pressure system. You can circumnavigate some of these air mass thunderstorms, but generally the visibility is good in the summertime across this area. I use Norfolk, Virginia, that Climograph to describe this area's climate and general average weather. Of course, this changes the further north you go. Like, for example, if I were to show you Boston's or New York City's Climograph, it would definitely have colder temperatures associated with those two as compared to Norfolk. But for Norfolk in the Mid-Atlantic region, the coldest month is January, where the average high temperature is in the lower 40s. And then that temperature climbs. That climbs up to the warmest month. The warmest time of year is generally in July and August in the Norfolk area, where the average high is in the upper 80s. All right, and then you see a drop-off in the fall, especially October, November, December. The frequency of cold frontal passages, it increases. You see a lot more cold frontal passages on the order of every 2 to 3 days moving through Norfolk area. And that's going to result in so much more cooler and more pleasant weather. Look at the precipitation. It's pretty evenly distributed by these blue bars throughout the course of the year. No one month shows less than 3.1 inches of rain or inches of precipitation in general on average. So there's a good example of the Norfolk, Virginia Climograph. Right, and so to end tonight's video, I wanted to just show you some of the major features that affect the United States weather. Thunderstorms are very big in the United States, especially east of the Mississippi River for air mass type thunderstorms. And then if you go between the Rockies and the Mississippi River, Central Plains area, you get more severe thunderstorms and a lot more tornado frequency, as I mentioned earlier. But in general, and I look at the average number of days with thunderstorms per 10,000 square miles, you notice the orange shading in Florida. They call that the thunderstorm capital of the world, right? Lightning capital of the world is in Florida, right? Tons of strikes of lightning associated with these thunderstorms. But generally 70 to 90 thunderstorm days each year in the state of Florida, and then you'll see it kind of spread back towards the westward there along Interstate 10 there. In the Florida Panhandle over to southern Alabama and southern Mississippi. So a lot of thunderstorms occur across Florida for sure. And then the darker green shading indicates 50 to 70 days with thunderstorms across parts of Georgia, Alabama, Mississippi, Arkansas, Louisiana, into Missouri, and parts of Tennessee. And then we decreased about 30 to 50 thunderstorm days per year across a large chunk of the United States. Now you'll notice the fewer than 10 there, the white shading over the western U.S. there. The reason there's so few out in that location is due to the stabilizing influence of the eastern Pacific high pressure system, as well as the colder ocean current, where you get more of a stratus vice a convective cumulus cloud all over that part of the United States. As far as tropical cyclone climatology, we're dealing with this right now. Hurricane Ida has moved into Louisiana today. Just a powerful, powerful hurricane. And this shows you from June and November, hurricane season. Generally, the average tracks of these tropical cyclones. So the peak of frequency of these occurs in late August and through mid-September. You'll notice the general tracks represented by the white arrows. And then the season runs through the end of November. So the U.S. has to contend with this mainly in the Gulf of Mexico and along the eastern seaboard. Looking at the general storm tracks throughout the course of a year. Now we're talking about mid-latitude, westerly winds pushing these storm systems along. These are the tropical origin. Now these are the regular mid-latitude extratropical cyclones. You'll notice that the average storm tracks generally move from west to east in all seasons. However, the general track is going to shift. The winter pattern is much further south. The summer pattern storm systems traverse the northern parts of the U.S. into northern New England. So there's a big shift generally between summer versus winter on the cyclone tracks across the United States. So I thought this was a really good map showing that difference. With the winter pattern, with the storm track much further south, it's due to the jet stream, the polar front jet stream, also moving further south and providing those dynamics in the upper levels of the atmosphere. As far as snowfall goes, these were statistics from 1961 and 1990. It's a little bit older, obviously, than the current climatology, but it does do a good job representing where you get the most snowfall in the United States. Generally, across New England, the purple shading indicating 48 inches plus on average each winter season. In general, the lighter grays indicate much less. And so you can see around the Great Lakes area, there's a lot of snow on average each year. And this is due in large part to the lake effect snow belts there on the eastern side of the Great Lakes areas. And then in the western U.S., you see the purple shading as well up in the higher elevations of the Rocky Mountains, where the air is much colder. And then also along the higher elevations of the Pacific Northwest down through California and the Sierra Nevada mountain range. Averages a lot of snow each year. So if you like snow, you need to go basically the higher elevations of the western U.S., or you go up to New England, upper Great Lakes area, Midwestern area, as well as the northern plain states. And then, this is the last slide I'm going to show you in tonight's video. I wanted to show you the difference between winter versus summer weather in the United States. Now, this is really significant. In general, in the wintertime, you get this warm air that tends to be much less dense, and it tends to glide up and over colder air at the surface. And so it's a much more gradual climb of this warm air. And as air rises, it's going to cool, it's going to condense, and it's going to form clouds. But these clouds are going to extend over much larger distances in the wintertime with these mid-latitude storm systems, these extratropical cyclones. If you look at the graphic on the far right, you'll notice these conveyor belts that are associated with these mid-latitude storm systems, or the extratropical cyclones. They have the frontal systems with them. There's a lot more temperature contrast in the winter as well because of much colder polar areas, and further south it's warmer. You get much larger temperature contrast, which energizes the polar front jet stream in the wintertime, which then sets off these areas of low pressure at the surface, these upper level disturbances, and then you get these conveyor belts, the dry conveyor belt, the warm conveyor belt, and the cold conveyor belt. But in general, what I'm getting at for wintertime, overall bottom line here, is that the clouds generally take on more of a stratiform appearance, more layer-like, and the precipitation is much more continuous in the winter season in the United States. Whereas in the summer, they look at the bottom left, look at that big puffy cloud there, the towering cumulus cloud, and the summer air mass weather is influenced more by these convective currents, where the air is heated, the ground is heated, and these red arrows represent that warm, less dense air rising in the vertical, and then you get this cool air that sinks in between these cumulus clouds, where you have these blue, clear openings And so you get this big, huge convective circulation or convective currents in the summer season, which is going to result in these sour and puffy cumulus clouds, and ultimately it's going to result in showers and thunderstorms, with precipitation being much more scattered in nature, where one area may get over an inch of rain on short order, and another area about 10 to 15 miles away gets next to nothing in the rain gauge. And so the precipitation in the summer tends to start and stop much more efficiently, much more quickly, and it tends to really precipitate to higher amounts in the summer season because the showers and thunderstorms, that those showers are much heavier. So I wanted to just kind of show you the differences here between winter versus summer. I thought these were some good graphics to represent that. All right, that wraps up tonight's video on the United States weather. We broke everything down by region. We looked at average snowfall, average storm tracks, the tropical cyclone tracks, generally through the hurricane season, June and November. We looked at thunderstorm climatology and various climographs representing cities in these various areas of the United States as we broke it down tonight. I really hope you got something out of this training. I'm looking forward to moving into more of the forecasting videos soon. I was considering making a video today for the upcoming week across the Mid-Atlantic and Southeast Virginia, but I'm going to hold off on that. I wanted to get this video out. This will probably be one of my last videos of the summer. We've covered a lot of interesting training topics over the course of the summer. Please feel free to go back and look at those here on the Spot on Weather YouTube channel. A lot of different interesting topics, but we're getting to that time of year now where we're almost into September, and just for example, this week, we're finally going to see some changes in the air mass. The remnants of Hurricane Ida are going to make their way generally into the northern Mid-Atlantic area. It's going to push a cold front. It's going to push a cold front through on the backside of Ida's remnants, and we're looking at some changes that are going to start happening here shortly as we head into the fall season. The winter weather forecast, the video from Spot on Weather, will be coming in October, as I previously mentioned, to close out other videos. The teleconnections discussion, as well as various forecasting videos. And so I'm about to shift gears here at Spot on Weather to more forecasting videos and teleconnections discussions, again, those weekly discussion videos describing the overall global circulation and how that can impact our weather locally across Southeast Virginia. Thank you so much for subscribing to our channel. I'm looking forward to much, much more in the months ahead as we head into the fall season. And I certainly wish everybody the very best. Hope everybody's doing well out there. And take care, and God bless everybody.